Pause. Hey there, economics students! Today I'm diving into the fascinating world of game theory and strategic behavior. Specifically, how firms use these concepts to develop optimal pricing and output strategies in competitive markets. So, what is game theory? It's a mathematical framework used to analyze strategic interactions between rational decision makers. It helps us understand how firms compete and make decisions, especially when their actions directly influence the outcomes of others. Now let's break down some key concepts. First, we have the players, the firms or businesses involved in the market. Next, we have strategies, the possible actions each player can take. For a firm, this might include setting prices, determining output levels, or choosing marketing strategies. Then, we have payoffs, the outcomes of these strategies, often in terms of profit or market share. Finally, there's the Nash Equilibrium. This is a situation where no player can benefit by unilaterally changing their strategy, assuming the other player's strategies remain unchanged. It represents a stable state where all players have optimized their strategies given the actions of their competitors. Alright, let's get into some specific models. First up, Cournot competition. This is all about quantity. Firms compete by choosing how much to produce, assuming the output of the other firms is fixed. The price in the market is determined by the total output. Imagine two firms, A and B, producing identical products. Firm A decides its output, and Firm B reacts. Each firm calculates the optimal output by considering the expected output of the other. Next, we have Bertrand competition, which focuses on price. Here, firms compete by setting prices rather than quantities. Each firm assumes that its competitors will not change their prices. The firm that sets the lowest price captures the market. Think of two gas stations, C and D, located near each other. If station C sets a lower price, it captures most customers. But if D lowers its price further, a price war could ensue. Lastly, let's talk about Stackelberg competition, the leader-follower model. One firm, the leader, sets its output first, and the follower reacts based on the leader's decision. Picture Firm E, a large player, setting its output first. Firm F, a smaller competitor, then chooses its output to maximize profit, given Firm E's decision. The Nash equilibrium here occurs when Firm E optimizes its output, knowing how Firm F will react. Now let's see these concepts in action with a real-world example, the airline industry. Airlines like Delta, American Airlines, and United Airlines constantly adjust their prices and flight frequencies based on competitor actions. In a Cournot scenario, airlines decide on the number of flights to offer. If Delta increases its flights on a route, United might reduce its flights to avoid oversaturating the market. In a Bertrand scenario, airlines often undercut each other's prices. If American Airlines reduces its fare, Delta might match or lower its price to stay competitive. And in a Stackelberg scenario, a dominant airline like Delta sets its flights first, and smaller competitors follow. In conclusion, game theory provides a powerful tool for understanding and developing optimal pricing and output strategies in competitive markets. By considering the actions and reactions of competitors, firms can strategically position themselves to maximize profits while anticipating and responding to market dynamics. Thanks for watching. If you enjoyed this video, be sure to like and subscribe for more insights into the world of economics.